In this video, we're going to be having a look at functions, but before we get into that, I know that it's been almost 2 months now since the last time I posted. I apologize for all of that. I've been very busy at work, but then now I'm back, and I promise to make sure that I share all these videos that are more advanced and explain to you and help you find better ways to basically approach those type of questions. So without wasting any further time, let us go into this question here. So the question here, it is read as follows. It says here, sketched below are the graphs of f of x, which is equals to minus 2x squared plus 4x plus 16, and g of x, which is 2x plus 4. A and B are the x-intercepts of f, and C is a point on f. All right. So now let's go ahead and read the first question. So the first question here, it says, calculate the coordinates of A and B. So now A and B, we can see that those are the points on f, and not only that, those are the x-intercepts. So it means now we know that in x-intercept, right, we always make y equals to 0. So now here we have y equals to minus 2x squared plus 4x plus 16. So now from there, we're going to make y equals to 0. And then we're going to continue with that. And then from here, we're going to solve for x. So by solving for x, I'm going to take the minus 2 across. And then it's going to be 2x squared. And then this one's going to be minus 4x. And then that is going to be minus 16 equals to 0. And then I will divide this by 2. Like that. And then this gives me x squared minus 2x minus 8 equals to 0. And then we're going to factorize here. So the factors will be x and x, and then 4 and 2. Then I'm going to say minus plus, and then x is going to be 4, or x is going to be minus 2. And from here, we can see that a is minus 2 to 0, or is going to be minus 2 to 0, and b, it is going to be 4 to 0. All right, and then that's how we get our first answer. So let's go ahead and look into the second one. So in the second one here, it says we need to find the coordinates of C, which is the turning point of F. So now the first thing that we need to do is we need to have a look at the equation that we have for F. So which is in this case, it is minus 2x squared plus 4x plus 16. Now here, to get the turning point, this is the standard form. So the formula that we're going to use, it is minus b over 2a, and then here we're going to have minus b is 4, and then 2, and then a is minus 2, and then this gives us the coordinate of 1. And then from there, we're going to take this, we will then substitute it into the original equation, because we want to find the y coordinate of what? Of the turning point. Then now here, when we do that, we basically get minus 2 1 squared plus 4 into 1 plus 16, and then this gives us 18. So our answer becomes 18. So the coordinates of C is going to be 1 is to 18. All right, so now let's have a look at 5.3. 5.3 now says now we need to write down the range of f. All right, so now when you're writing the range of a parabola, it is very important that you look at the value of a from the standard formula, and also the y coordinate of the turning point. Now here in this case, because of a is what is negative, it means our graph is a set face, or it has a set shape, and not only that, it also has a maximum. So this then means now if we want to write a range for when your a is less than 0, you always say y is less or equals to the y coordinate of the turning point. Now, if your a was positive, you would have said y is greater or equals to the y coordinate of the turning point. Now, in this case here, we see that the value is negative, so which means we're going to be going with the first one where it says y is less or equal to the y coordinate of the turning point, and in this case it is 18, and then that's going to be our answer for the range of this graph. All right, now 5.4 says that the graph of h of x, which is equals to f of x plus p plus q, has a maximum value of 3 at x is equals to 2. Now determine the values of p and q. Alright, now here what is happening here? So basically here what's happening is there's a new graph of h of x, but then this graph is formed, right, from shifting the graph of f horizontally and also shifting it vertically, right? Now the shifts here, when the shift happened, what happened was the vertical shift changed the maximum value from 18, because if you remember here, we had 1 is to 18. It shifted it from 18 to 15, so which means it dropped by 3 units, right? And then the horizontal shift here, if you remember the x coordinate here, it was 1. Then on the horizontal shift, it shifted the graph to the right by 1 unit, and then the very first it was x is equals to 1, then now it is x is equal to 2. Now to find these values of p and q, it's very simple. All we have to do is to look at the shift that has happened and then write from straight there. Okay, now in this case here, to get the value of q, right, we know that firstly, initially our graph was had a y value or a maximum value of 18, but then now it has a new maximum value of 15, so it means it has been shifted 3 units to downwards. So now if you had 18 then and you add minus 3, then that means that's your value for q. So in this case here, q is going to be minus 3. Now what about p? Now if you remember, this is a what? This is a horizontal shift, right? So because of this is a horizontal shift, it means now the value here has been shifted to the right, because it was firstly at x is equals to 1, but then now it is at x is equals to 2. So now remember, when you're shifting your graph to the left or right, if you're shifting it to the right, then it means this value needs to be negative, right? And then if you're shifting it to the left, it means it needs to be positive, right? Already it is at 1, right? Or if I'm thinking of the shift, it has already been on x minus 1. So now if we're shifting it to x is equal to 2, it means I need to shift it 1 unit to the right. So therefore, because of I'm shifting it to the right, that shift, it must be a negative value. And here, because of I shifted it by minus 1, it means now my value, it is going to be minus 1. Now, of course, this is just for them to test if you understand this, right? Now, if you want to get a better understanding, it's easy for you to actually simplify everything from there and then find the turning point after that. And then after finding the turning point, and then you just work from there, right? So that's the easy way of doing it. But the purpose of, sorry, that's another way of doing it. But the purpose of this question here is to see if you can be able to visualize it. Hence, the mark here is 3 marks, right? So that is basically our answers for 5.4. And so right now let's have a look at 5.5. Now 5.5 here says determine the equation of g inverse, which is the inverse of g in the form of y is equal to that. All right, so now here we know that y is equal to 2x plus 4. Now to calculate the inverse, it means I must first solve for x and then swap the variables, right? So now firstly I will solve for x, so I'll take this 2x to the side minus 2x, and then from there I will take this y to the other side, so that will mean I'll have minus y plus 4. Then I'll just divide by minus 2 everywhere. So by doing that, I have x is equals to 1 over 2y minus 2. And then from here, you see I've said solve for y, so therefore I swap the variable like that. So this now is what we call the inverse of g. Alright, so now let's have a look at 5.6. Now 5.6, it goes as follows here. So 5.6, it says for which values of x will g inverse x times g of x be equals to 0. Alright, so now here, first of all, we don't have the sketch of the inverse, right? So which means we need to think through everything to make it simpler. Alright, now here we are given this product and then they're saying it's equals to 0. Now we know that this product can only be 0 if the first part is 0, right? or the second part is 0. Now this inverse, remember, don't forget about it, these are the y values, right, of inverse, right? Now if the y values of the inverse are equal to 0, then this means now this is actually what? This is actually an x-intercept, right? Because that's the only time we get a y value to be equal to 0, only at the x-intercept. Now the same is true here. Now these are the y values of g of x, and it means this is what? This is the x-intercept of g, right? Now to get the x values, now we'll only just calculate these x-intercepts, right? So let's start off with the first one. So the first one, x-intercept, this y is equal to half here. Let me just write it. Half x minus 2, right? So we're just gonna make this equal to 0. So 0 will be half x minus 2, and then this will be 2 equals to half x. Then I'll cross multiply there, and then 4 will be x. So therefore the x value here will be x is equals to 4. Now what about the other one? So the other one here is for g, right? So we know g, that when g here, let me just write g here, and the y value of g is equal to 0, that's also another x-intercept. So we make this 0, and then we make that, take this across, we make it minus 4 equals to 2x, divide by 2 both sides, so minus 2 becomes x, and therefore x becomes minus 2, right? So these are the values where x is equal to minus 2 or x is equal to 4. Now these are the values where this part, this product becomes 0, and also same applies. X minus 2 gives you this product equal to 0, or and x is equal to 4 makes this product to be equal to 0. Of course, this part here, it's not necessary for you to write it. You can just visualize it, because here the idea here was to show you how did we get into the answer that they wanted us to answer. All right, so now let's have a look at 5.7. So 5.7 goes as follows. If p of x is equal to that, determine the values of k for which p and g will not intersect. All right, so now here we basically want to find the values of k, right, for which the equation of p and the equation of g won't actually intersect. Now the easy way to do that is to take the value or the equation of p of x, right, and equate it with the equation of g of x, right? And from there, we will need to find the nature of the roots, where the roots here will be undefined, because if the roots are undefined, it means they won't touch each other. All right, so now here, what is p of x? P of x, if you remember, it is f of x plus k, and then g of x, of course, it is 2x plus 4. But we do know the value of f of x. So f of x, it is minus 2x squared plus 4x plus 16, but we still have our k there. Now this is 2x plus 4. So what I'm going to do here is I'm going to make this a standard form. So I'll take this 2x across, and then I have 16. I'll take this 4 across, and then I have k equals to 0, and then I will find the nature of roots for which this is non-real, because when the nature of roots are non-real, it means they do not intersect, right? Okay, so now from here I have minus 2x squared plus 2x plus 12 plus k equals 0. Now here the value for a is minus 2, the value for b it is 2, and then the value for c it is 12 plus k. Then therefore I will say delta of b squared minus 4 ac must be less than 0. So by having it thus, it means non-real. So the word non-real, it is the same as not intersect when it comes to two graphs, right? Not intersect. Okay, so now here, what is my b here? It is 2 minus 4 into minus 2 into 12 plus k less than 0. Then this is going to be 4, and then this will be 8 into 12 plus k less than 0. And then I have 4 plus 96 plus 8k less than 0. This looks like 100 plus 8k less than 0. And I have 8k less than minus 100 divided by 8 divide by 8, and then k will be less than, press that on a calculator, negative 100 divided by 4 is going to be divide by 8, not 4 here, divide by 8 to be minus 25 over 2, and that will be the value for k. And that is all for this video, and that's all for this video. If you haven't yet done so, please make sure that you subscribe and also share this with your friends. Maybe this might be something that they might benefit from. And thank you so much for watching, and until next time, stay blessed by the best. Cheers.